Welcome back. In this video, we're going to try to find the limit as x goes to 0 from the right of this function. Our function is defined by the integral of 1 over the square root of e to the power t minus 1, and we're going to integrate between the natural log of 2 and x. Here, x is in 0 plus infinity. Okay, we don't want x to be 0 here because we can have another problem in this integral. Okay, when x is 0, we're going to have a problem here in the definition of the function, and we don't want to have another improper integral. That's why we take the limit. We are looking for the limit of this function as we get closer and closer to 0 from the right. Okay, so here one way of finding this limit is we can find the primitive. Okay, we can find the primitive of our function by using a change of variable. Okay, and the easiest way is to get rid of this fraction of the square root. That's why we're going to use this change of variable. We're going to let u to be the square root of e to the power t minus 1. Okay, first we're going to change the bounds. When t is the natural log of 2, u is going to be 1. When t is x, u is going to be the square root of e to the power x minus 1. And we have to find dt. Okay, to find dt, we're going to differentiate. Du is going to be 1 over 2 e to the power t over the square root of 1, or e to the power t minus 1. Exactly, this is what we need. Dt. Here we know this one. This is u. So we have 2u du et dt, and we have to find et. Here et is, if we square both sides, we're going to have u squared, and we add 1 here, we're going to have et. So et is u squared plus 1. Okay, so it's u squared plus 1. Dt is 2u du. Therefore, dt is 2u over u squared plus 1 du. And that's what we need here. So here we can now integrate. F of x is the integral between 1 and the square root of e to the power x minus 1. 2u over u times 1 plus u squared du. Okay, this u is coming from this change here. Okay, and we have 1 over that. That's mean 1 over u. Okay, we can simplify one more step here. So here it's ex minus 1 over 1 plus u squared du. Okay, now we have a key idea here about the primitive. So we know this one here. So here we know a primitive of this one, which is the arctangent of u. Okay, if we differentiate the arctangent, we're going to have 1 over 1 plus u squared. Therefore, this is the primitive. Okay, we're going to use this one here. So we have the arctangent of u evaluated between 1 and the square root of e to the power x minus 1. Okay, so we're going to have our function f of x is going to be the, I need a 2. I think I missed a 2 here. So 2, I need a 2 here in the front. So 2, I need a 2 here. Because when I did the change here, it's here. So it's still here, but I didn't move it to the front. So here it was right, but here it was wrong. I needed to have the 2 in the front. So I'm going to have 2 arctangent of the square root of e to the x minus 1 minus arctangent of 1, which is pi over 4, but with the 2 I'm going to have minus pi over 2. Okay, now I can easily find the limit. So the limit of f of x, as x goes to 0 from the right, it's gonna give me here. So this is e to x, because the arctangent is continuous, I can't take the limit inside, so it's gonna give me 2 e to 0, which is 1 minus 1, which is 0. So this is 0, and this is minus pi over 2. That means the limit is minus pi over 2. Okay, so therefore I don't need to do any computations since I found what I need. Okay, and in the next we're gonna see what we can do with this one. What does it mean? What does it mean to for this integral to have this value minus pi over 2? What does it mean for this integral? Okay, so I found the limit. Now we need an interpretation for this. I leave it to you in the comment section. Please tell me what does it mean for you to have this limit. Thank you very much.